And dear everyone, professors, colleagues, and to professionals from both industry and academia, thanks for coming to my presentation today. So this is Hongbing Fan, a PhD student from the Department of Agriculture, Food, and Nutritional Science, under supervision of Dr. Jianping Wu at the University of Alberta in Canada. So it is a great opportunity to present through this virtual meeting. Now I'm here to talk about the new progress on spent hemp proteins for value-added applications, and especially with the ability to control high blood pressure. So I will first introduce a little bit background for spent hens in terms of the traditional processing and ongoing value-added applications, and then introduce the spent hemp muscle protein hydrolysis, which was prepared by thermolysin. Thermolysin, which is a microbial like protease, and investigated its antihypertensive effects. So what is spent-hem? So spent-hem are those egg-laying hens which reach the end of their egg-laying cycles because the egg productivity reduces, therefore becoming a byproduct. So the egg-laying cycle is around 1 year usually. And in 2018, there are more than 1,000 egg farms registered in Canada. And for each person, so it usually consume around 21,000 eggs per year, and the egg laying productivity per hen is around 280 eggs per year. So here are some statistics from the Agriculture and Agri-Food Canada. And we can see a continuously increasing trend of spent hen production from 2005 to 2019, from around 26 million to 35 million. So this is a huge number of spent hens. So how to deal with such a huge number of spent hens? It is a big problem, to the ag industry and to the ag farmers. And as you can see, in this image, the left one is the spent hen carcass, while the right one is the broiler, which is mainly for chicken meat production. And you can easily tell spent hen meat is not of high value, and with low meat yield and quality, has a tough texture, a lot of tiny bones, and therefore is not liked by food manufacturers and also consumers. And they are usually disposed by burial, composting, or incineration, which cause animal welfare and environmental issues. So finding an alternative way for spent hen utilization is expected. And also spent hen is byproduct. It is a rich source of animal proteins. And within the past few years, there are mainly two value-added applications explored. And both of them are focusing on proteins. And one is through chemical modification to fabricate protein-based biomaterials. And another one, which is through biotechnology such as enzymatic hydrolysis, to generate bioactive peptides for functional food applications. And here are some articles for the biomaterial and the functional food application of spent hen proteins. So such as the adhesive and hydrogel and the collagen hydrolysis, the bioactive peptides, and to prepare the molecular weight collagen peptides, and also the stability and the bioaccessibility of the bioactive peptides. So if you are interested in these studies, I highly encourage you to read these articles. And here are an overview of the current value of value-added application of spent hens. And for the biomaterial application, it's mainly including it mainly to process proteins into hydrogels or protein-based and more environmental friendly adhesives and bioplastics. And the muscle protein can also be processed by enzymatic hydrolysis, to produce functional food ingredients. It is mainly bioactive peptides, and it's with special focus on anti-inflammation and anti-hypertension. And also because spent hen has a lot of high proportion of collagen, so especially from skin, bone, or feet. So the collagen can be extracted and to make low molecular weight collagen peptides, and this can also be processed into gelatin and to form hydrogel as well. And as you know, as you can see that actually our lab is continuously exploring more health beneficial effects of SpanHAN proteins in order to provide more scientific evidence to process SpanHAN proteins into functional food ingredients. And as you can see that the functional food ingredient application of SpanHANs is mainly centering, focusing on bioactive peptides. The bioactive peptides are short amino acid sequences, usually containing like 2 to 20 amino acids, which possess biological or physiological activities beyond the basic nutrition as amino acids. And by now, various biological activities have been identified, such as like antioxidant activity, anti-inflammatory activity, antimicrobial activity, and antihypertensive activity. So here I want to point out that meat proteins are excellent sources of antihypertensive peptides. In a previous study comparing the potential of various food proteins in producing ACE inhibitory peptides by thermolysin, so it shows that chicken muscle proteins contains a lot of ACE inhibitory peptides. The ACE represent angiotensin converting enzyme, which is a very important enzyme in regulating blood pressure. And thermolysin is a microbial protease, which is very effectively in producing ACE inhibitory peptides. So this led to a hypothesis, which is SpanHAN muscle protein hydrolysis prepared by thermolysin can reduce blood pressure in spontaneous hypertensive breaths. And we firstly extracted SpanHAN muscle proteins using a pH shift method as described in this article. And then thermolysin has been used to hydrolyze the protein and to prepare this hydrolysis. And we have to validate, even though there's publications that showing that thermolysin can release more ACE inhibitory peptides or antihypertensive peptides from the hydrolysis, but we still need to validate these in vitro activities. So we select these two activities mainly based on their importance in regulating blood pressure, and I will give a little bit more information later. And then after confirming their in vitro activities, the hydrolysis has been already administered to the animals, and they investigated the antihypertensive mechanisms. So here are some information about the Renin-angiotensin-system, which is really important in blood pressure regulation. And in the RAS, angiotensinogen, which is from the liver, can be converted by an enzyme called renin, which is from the kidney, to form angiotensin-1. And then angiotensin-1 will be further converted by ACE to form angiotensin-2. And angiotensin-2 will bind to angiotensin-2 type 1 receptor, and then this pathway will lead to an increase of blood pressure. And on the other hand, there is another enzyme called ACE2. ACE2 is a homology of ACE, and it will convert angiotensin-2 to form angiotensin-1,7 and binds to the MAS receptor. This pathway will lead to a decrease of blood pressure. And also ACE2 can degrade ACE angiotensin-2, so it can actually lower the level of angiotensin-2. So it will further reduce blood pressure through downregulating these pathways. So it would be great if there's hydrolysis which can inhibit ACE and increase the level of ACE2, which will be an ideal candidate for in vivo blood pressure reduction in animals. So here are some in vitro result of ACE inhibition and the ACE2 upregulation of the hydrolysis. And here I actually use the hydrolysis. The sample is with a lower molecular weight, it's lower than 3 kilodalton. And then we can see that the sample has a very low IC50 value of ACE, 14 microgram per mil. So which means it has a really strong activity in inhibiting ACE. And to the right, so we can see that the sample can upregulate ACE2 in a dose-dependent manner, and significantly in the vascular smooth muscle series. So after validation of these in vitro activities, so the animals, the hydrolysis has been fed to the animals. So the animal model we used here is called SHR, is spontaneously hypertensive rats. They are all male, and at an age of around like 12 to 14 weeks old, and there are mainly like three groups. So untreated and low dose and high dose group. So the dosage were selected mainly based on our preliminary study and also the publication in literature. And to the animals, like so we monitor the blood pressure change like using a telemetry technology. So which is mainly like say we did the surgery to the animal, and so the transducer will be implanted into the animals and connected with the blood vessel, and the animal will be left on a receiver, and the receiver will transmit the signal to the computer. After processing, it can produce blood pressure values. This is really accurate way to monitor blood pressure. So as you see, like the result here, that you can see that both the low dose group and the high dose group significantly reduce the blood pressure. And I take the systolic blood pressure as an example. So on the day 20, so we can see that like for the untreated group, so the blood pressure is around like 170 milliliter mercury, and we can see that like in the high dose group, it's reduced to around like 140 milliliter mercury. So it is like huge like reduction of blood pressure, and the mean arterial pressure and the diastolic blood pressure like also showed the same trend. And the good thing is like the heart rate was not significantly affected like after feeding the hydrolysates. So by looking into the mechanisms, so we first tested the vascular function using the isolated mesenteric artery for an ex vivo study. So because the blood pressure is mainly from two portions, like say the cardio output and the peripheral resistance, and the mesenteric artery contribute substantially to the total peripheral like resistance, and therefore to the arterial blood pressure. So we already compared the vascular function in two groups, the untreated and the high dose group. So the idea here is to first to pre-constrict the vessel using some vasoconstrictory compounds. Here I use like is per phenylalanine. So and then to slowly increase the concentration of methyl-choline, which is a vasodilator, and to see how the blood vessel in different groups respond to the methyl-choline. And here we saw like there was no significant difference in the vasodilation of these two groups. And by looking into the mechanisms, like we first look into the contribution of nitric oxide like to the vasodilation, and L-name is an inhibitor of nitric oxide. So by inhibiting nitric oxide, we can see that actually there are huge like difference. And so in the high dose group, we can see a substantially slower decrease in the vasodilation after adding the L-name. So which indicated that the high dose group has shifted the vasodilation to be more towards nitric oxide dependent. And we can see it is like very significant. The reason we then tested the expression of enos in the aorta. And enos like represent like endothelium nitric oxide synthase, which is the primary enzyme in producing nitric oxide in blood vessels. And then we found that like the high dose group, it has a higher expression of enos, and also like even though the high dose group did not directly cause like more vasodilation, because the rats we used here is in a very young age, and we could expect that the hydrolysis might cause more vasodilation in aged models, in aged animals, because in aged animals, they had a more like substantial decrease in nitric oxide generation and the lower nitric oxide bioavailability when the animal become aged. And then like there was no difference in the nitric oxide independent vasodilation. And for the RAS component in the circulation, so the ACE activity was not affected. The ACE2 levels they appear to be increased, but being not significantly. And angiotensin 2 were significantly reduced, while the angiotensin 1.7 were significantly increased. So, and in addition to the circulating RAS, the local RAS also has a big impact on blood pressure. So we found that in aorta, like ACE2 expression and was significantly enhanced, and the angiotensin 2 type 1 receptor was significantly downregulated. And the ACE2 appeared like to be downregulated, but without a significant difference. And there was no such like difference between in terms of the expression of angiotensin 2 type 2 receptor and to MAS receptor. And the vascular inflammation like contributes to like high blood pressure as well. So we tested both these inflammatory cytokines such as like the TNF alpha or MCP1, and the expression of inflammatory biomarkers in the aorta such as INOS, COX2, ICAM1, or VCAM1. And we found that like the TNF alpha and MCP1 in the circulation were significantly reduced, and the expression of INOS and VCAM1 was significantly upregulated, where there's no much difference like in the expression of COX2 and ICAM1 in the high dose group. The vascular fibrosis leads to less elasticity of the blood vessels, causing hypertension and vascular disease, such as atherosclerosis. And TGF-beta represent transforming growth factor beta, induces cell growth like proliferation, differentiation, like inflammation, and fibrosis. And we can see that in the circulation in the plasma that the TGF-beta has been significantly reduced in the high dose group. In the type 1 collagen is an important marker indicating the fibrosis of the blood vessel. So in the high dose group, you can see that the expression of type 1 collagen was significantly reduced. So to wrap up, so the spent muscle protein hydrolysis reduced like blood pressure in spontaneously hypertensive rats, mainly via like these 4 pathways. So by improving nitric oxide dependent vasodilation, by modulating the RAS components, both like in the circulation and the local levels, and by attenuating vascular inflammation and vascular fibrosis. So and then together like to reduce blood pressure in the animals. So the take-home message here is our finding like further demonstrated the potential of spent proteins to be processed into functional food ingredients for hypertension treatment. The increasing evidence of the health beneficial bioactive components in spent proteins will contribute to developing a more sustainable solution for the disposal of spent hands. And the future study like might be like first like to identify the antihypertensive peptides like from this hydrolysis, especially for ACE2 upregulating peptides, which will be a novel peptides for antihypertension, and then to ascertain whether the anti-inflammatory or anti-fibrotic effects are independent or dependent of the RAS. And then like lastly, like it would be interesting to test the hydrolysis in aged like animals, because the hydrolysis shifted the vasodilation to be more towards nitric oxide dependent manner. So while in the aged animals, like it has a substantial decline in nitric oxide production and bioavailability in the vasculature. So which means that nitric oxide dependent vasodilation plays a more important role in the aged models, in the aged animals. So thanks for your time and attention to my presentation. And if you have any questions, just feel free to send me an email. I have left my email box on the cover page.